Thank you. All right. Hello, everyone. We're going to shift gear and move to the next session. My name is Kerk Kee, Senior Personnel with CI Compass and also Associate Professor of Media and Communication at Texas Tech University. And for those of you I haven't met, I'm a social scientist of cyber infrastructure and Science Gateway. And I also study the social and organizational processes surrounding the adoption and implementation of these technologies, including in the MF context. And today, we're here to discuss the topics of resilience and uncertainty management during a difficult time, such as during the COVID-19 pandemic. The last 2 years, we have learned that the unthinkable, such as a global pandemic, can indeed happen. And I wasn't prepared for it. And many people around me were also not really prepared for it. But here today at CI Compass, during this workshop, we're going to explore how to identify that resilience compass going forward to guide us in thinking about challenges and difficult time. So what exactly is resilience? I did a little Google search and I was looking for some visual and textual definitions of this concept. And that it was interesting that in terms of visual images, I saw that there were pictures that show and suggest a sense of physical strength, such as the ability to resist challenges and hanging on when the going gets tough. And then I further look for a textual definition and found a definition from Psychology Today. It states that resilience is a psychological quality that allows some people to be knocked down by the adversities of life and then come back at least as strong as before. And this definition is interesting in that it adds a psychological notion to the definition of resilience, that a resilient person is not simply physically strong and cannot be knocked down, but psychologically strong to get back up and bounces back when the situation is difficult. And this is an important psychological quality of resilience to keep in mind. And I searched further, and then I found this paper by Steve Wilson, Patrice Busnell, and others at the University of South Florida. And they add another interesting view on resilience. They suggest that resilience is a communication process that unfolds in response to a single or series of disruptive events. And it involves adapting and transforming and is created through interaction. They suggest 5 specific communication processes, including constructing alternative logics, and more importantly, foregrounding productive action while backgrounding negative emotions. And it is this point on foregrounding and backgrounding that I would like to demonstrate with these 2 pictures. So the photographers of these 2 pictures could have really focused on the rest of the land, focusing on the dryness and bareness of the ground and dirt. Which is also factual. However, they chose to focus on the tiny life that emerged from such a difficult and almost impossible environment. So in other words, resilience is a conscious choice to focus on the positives despite the challenges in the background. So what is the resilience then? It is all these. The physical and psychological strengths to resist, hang on, and bounce back, and the conscious communication actions to engage in reframing and foregrounding the positives among the negatives and to focus on what inspires us to stay on the goal and keep going forward. So with this brief overview, I would like to now introduce our first speaker, who is going to help us. We have 2 speakers to help us set the stage and think about resilience in the context of MF before the breakout session. So Cassandra Hayes is a PhD candidate in media and communication at Texas Tech University. Her dissertation in progress is an examination of the communicative forces that bring together the CI community. And the title of a presentation is No Hitting the Pause Button. And now I will turn your attention to Cassie and let her present her talk.
All right, so no hitting the pause button. So this project is about leveraging advanced cyber infrastructure and developing organizational resilience for NSF MFs in the pandemic era. So here's the research team for the project, which includes Kerk and Ava, myself, and Alex Olshansky. And this project involved us interviewing 13 so far MF professionals across the country to kind of get their experiences and perspective as they pivoted following the COVID-19 pandemic. And we are really asking, what were some lessons learned as MFs pivoted from this pandemic? We basically want to document and share these lessons so we can boost that workplace resilience in MFs broadly when facing various risks and crises, maybe even beyond pandemics. Our preliminary analysis of those 13 interviews we've conducted so far yielded 10 lessons learned to boost MF resilience, 5 pandemic response strategies, and 5 qualities of a pandemic sensitized mindset. And I'll go through each of the lessons we found kind of briefly here today. So beginning with those pandemic response strategies, we found first the need to promote flexible expectations at work. During a crisis, just carrying on with the same old workflows will not be successful. Secondly, we found the need to encourage information sharing within the community, as reaching out for help can provide solutions to problems, and also sharing knowledge can provide camaraderie and help make sense of this very confusing situation of a crisis. In fact, our participants often expressed regret at not sharing more during the initial stages of COVID, just because they didn't think about sharing at first when they were focused on their internal response. And point 3 here, we also uncovered a need to create optimal alignments across institutions. Although those layers of institutions that MFs often function within, such as funding agencies, state and national like policies, and sometimes even university policies as well, those can sometimes create confusion, but the stability of that institutional guidance really helped MFs navigate the COVID crisis. And the last 2 pandemic response strategies we found include sensitizing teams to risk to balance safety and productivity, and to keep work going despite those pandemic challenges. So it's important to both remain compassionate and flexible, but keep moving those essential work tasks forward despite the crisis and the confusing time. For instance, one participant described how a team member became ill with COVID early in the pandemic, which made the crisis very salient to the team, helping them learn early on what to expect and how to pivot when necessary. So moving on to mindsets, those strategies are more action-based and prescriptive. These mindsets are more descriptive qualities, a frame of mind. So mindsets include knowing vulnerable areas that might need response in a crisis, as well as keeping in mind that there's a people impact and a social impact of this research and this work. So acknowledging that no science is an island, so science cannot be separated from world events, and looking for socio-technical solutions to problems. So going beyond just what technically will work best. For instance, some of our participants described situations where technically they had a really fancy video conferencing platform that they thought would work better because of the increase in capabilities and security, but they ended up having to go back to what's most human accessible and easy to use during the confusing time of the pandemic. The final 2 lessons learned in our preliminary analysis include integrating the personal and professional in workplaces and cultivating a readiness to adapt to the new normal. For instance, a participant brought up knowing that their team was facing burnout and stress, and other participants brought up, working from the kitchen table. So there's children running around during their work. The pandemic further blurred boundaries between personal life and professional work environments, and further emphasized that modern life is all about constant change. So the new normal is really that there is no stable new normal. So those were the 10 lessons learned in our project so far with our first 13 interviews. We're still looking for interview participants, actually. So if you do want to be interviewed by me or a member of the team, please reach out and sign up for an interview with us. So that's all I have. And I guess I'll pass it back to Kerk now.
All right. Thank you, Cassie. So next we have Shafaq Chaudhry, who is the Director of Research Technology at the University of Central Florida. She leads a team of research facilitators and IT professionals, and the title of her presentation is Resilience in Major Facilities.
All right. Thanks so much, Kerk, for the introduction. And can everyone see the screen?
Yes.
Okay. Let me just. All right. So I'm going to speak briefly on the resilience topic in major facilities, and specifically I'm going to speak from the aspect of the Arecibo Observatory, which is an NSF major facility located in the small island of Puerto Rico. This observatory was founded in 1963, and it had the honor of being one of the largest single dish radio telescopes for 53 years until 2016. And recently, the management of this facility was transitioned over to a UCF-led team. So that was in 2018. This observatory has contributed to many significant discoveries over the years, including the observations of pulsars that captured a Nobel Prize in 1993. It is also one of the key facilities in the US for monitoring nearby asteroids. And one of the cool things is that it's very multidisciplinary, and scientists around the world conduct research in the areas of atmospheric sciences, planetary sciences, radio and radar astronomy. So you might be wondering, why was the Arecibo site chosen as the location for this observatory? Well, there are three main reasons for that. A, it was a government-funded project, so it needed to be on the US soil. B, in order to study the near-Earth orbit bodies, you have to be located closer to the equator. And C, they found a sinkhole that was large enough to hold that large dish. So this location, however, also meant that it is in the path of Atlantic hurricanes and storms. And in fact, 2017 was a catastrophic period because specifically in September, the whole island was hit by two major storms, one after the other. Hurricane Irma, which was a Category 5 hurricane, and 2 weeks later, Hurricane Maria, which was Category 4. And Hurricane Maria is considered to be one of the deadliest US-based natural disasters. It resulted in a lot of lives being lost, as well as economic damages estimated to be around $90 billion. And for several months, the island was without power. It was pretty much disconnected from the rest of the world. And the roads were blocked as well because the trees were down. So all in all, a very difficult time. And specifically for the observatory, there were also significant damages, and it lost the line feed, which was the 96 feet long radio transceiver kind of looking down, which broke and fell on the dish. It caused damage in several areas in the dish as well. And they also lost one of the smaller dish that was a 12-meter one. And because they have generators, they were able to kind of resume power within a week. But the staff had to work at that point to, work on the damage assessment, figuring out what type of repairs are needed, and then figuring out a plan for funding in order to make those repairs happen. So fast forward to 2020, that was another year filled one after the other with challenges. And the year started with a swarm of earthquakes. And here you see the earthquakes and the aftershocks. And this graph is only showing a window of a couple of weeks between December 2019 and first week of February in 2020. And you can already see that the dots are innumerable here. And the massive one was on Jan 7, which was at a 6.4 magnitude. And within that week itself, you can see that there are 6 major earthquakes right there. So while the island was dealing with these earthquakes, you know that the pandemic hit in March, and the government mandated a curfew, which caused the staff to transition to remote work in mid-March. The observations were also put on hold for a couple of weeks. And a couple of months after that, in August, one of the auxiliary cables broke. And at that time, the Arecibo Observatory staff, UCF and NSF, worked on a repair plan. And however, before they could perform the repairs in November, the main cable broke. And at that point, NSF made the decision to do a controlled decommission of the telescope due to the instability of the platform. But before that could be executed, on December 1st, the entire 900-ton platform fell, and the dome came crashing down on the dish. And you can see the impact and some of the damage here in these pictures. So what followed immediately after were safety protocols and making sure that the personnel are safe. Secondly, to do damage assessment in order to determine the safety of the remaining structure. Also, an environmental assessment needed to be conducted because of all the debris that had fallen in and around that area. The Arecibo Observatory staff also worked to restore operations to part of the facility, and that's because the facility does host many scientific instruments in addition to this telescope. So for example, it has a LiDAR facility, and there's also another smaller radio telescope which did not sustain much damage during this collapse. So they were able to start working on restoring those back online. And additionally, of course, the scientists wanted access to the data from the observations that have been collected over the decades. And that right there is that rescue mission that has already been mentioned in the previous talks. And it was seriously a major collaboration effort between several partners and various institutions as well as industry to make this data available at TAC, which is another NSF-funded facility, as you know. So in summary, what I can say is that Arecibo Observatory's history has been replete with many disasters spanning geophysical, meteorological, biological, and it has survived through them, right, in some way, shape, or form, and that is resilience right there. And this resilience is owed to its ability to anticipate risks and prepare for them, having safety protocols in place, such as hurricane lockdowns, a lot of coordination efforts with the sponsors, having damage assessment plans, also recovery plans after damages. And a very important thing is the communication with the researchers. So although the telescope left a void, but this scientific community that revolves around this telescope is also a very resilient one, and already the astronomers and the scientists have delivered a white paper proposal to NSF for building the next generation radio telescope at this very same site. So with that, I just want to thank everyone for listening, and just sharing a couple of pictures when I visited there, and the opinions expressed are my own. So thank you. Back to you, Kerk.
Thank you, Shafaq. All right, so we're going to transition back to my slide and prepare all of us for the breakout sessions.